Welcome to the tutorial on series clipper. A series clipper will have a diode in series with the output or the input. So this is a simple configuration that I have, wherein you can clearly see the diode D is in series with the input as well as with the output. Now, unlike the half wave rectifier circuit that we have seen in the tutorial, we will consider the waveform, input waveform, to be a square wave, as we have discussed in the introduction of the clipper circuits, that we can have any type of input waveform, a square wave, sine wave, or a triangular waveform. So here we will consider the input waveform to be a square wave having a positive amplitude plus Vm and a negative amplitude minus Vm. The duration of this particular square waveform is from 0 to t. Now, since there are no DC supply in the circuit, and we can see that the cathode part of the diode is connected to the ground, we will consider the transition voltage as visible from the circuit to be equal to 0 volt. So this is our reference, and we will analyze the circuit similar to that of the half wave rectifier circuit. You can observe that link is available on the top right corner as to how we have analyzed the half wave rectifier circuit. In a similar manner, we will analyze this circuit for a positive half cycle and a negative half cycle. So during the positive half cycle of the input signal from 0 to t by 2, you can see that the anode will have a greater potential because the amplitude is greater than 0. So it will have a greater potential in comparison to the cathode because the other end of it is grounded, and hence the diode will be forward biased. It will act as a short, and the equivalent circuit can be drawn like this. And since we have given a positive amplitude, I am going to mention this as plus Vm. Diode is acting as a short. Output voltage is measured across the resistance R. Whatever you have given as an input will appear at the output side. So output will be equal to plus Vm. Now during the negative half cycle, for a duration from t by 2 to t, you are giving a negative amplitude minus Vm, which is below the 0th level, below the transition voltage of 0. So what happens in such a case is that the anode potential will be negative, whereas the cathode potential is at ground, that is 0 volt. So we know that the negative voltages are less than 0 volt, because of which the diode is going to be reverse bias, and this will act as a open circuit. Now what happens is that our equivalent circuit would be resistance output, and we have given a negative amplitude, because of which there is no current that is flowing in the circuit, and since the other end of the resistor is grounded, the output is going to be equal to 0 volt. So for an input that is mentioned here, we will have an output waveform which will give us a positive amplitude from 0 to t by 2 with an amplitude of plus Vm, and the output is going to be equal to 0 for t by 2 to t. So what we basically have done is we have clipped off the negative half cycle of the input, and that is why this is going to be a negative clipper, and it is also a series clipper because the diode is connected in series with the input or in series with the output. That is why if you have observed in the introduction slide, I said the representation is not unique. Series clipper circuits can also be negative clippers or positive clippers. Now my question would be, how do I obtain a positive clipper, a series positive clipper? So all I need to do is I need to change the orientation of the diode. So when I change the orientation of the diode for the same input, this is going to be the circuit. Input is given here. Now when you analyze during the positive half cycle from 0 to t by 2, if you observe, your anode is at 0 volt and your cathode is having a potential which is very much greater. In this case, what happens is that your diode is going to be reverse bias. Whenever the diode reverse bias, it will act like a open circuit and there is no flow of current, because of which the output voltage will be equal to 0 volt. Whereas during the negative half cycle of the input from T by 2 to T, what happens is that this is at 0 volt, this anode is at 0 volt, whereas the cathode will be at a negative voltage. So as you know, as we have discussed earlier, 0 volt is greater than the negative voltage, because of which your diode is going to be forward bias. It will act like a short circuit and the output voltage will be same as what you have applied at the input side. And at the input side, since we are applying a negative voltage, the amplitude would be minus plus Vm. That is why at the output side you get this as minus Vm. So if I were to draw the waveform now for the output, I would have got it as, for a voltage from 0 to T by 2, you get this as 0 volt, and from T by 2 to T, you get this as minus Vm. So this would be the output waveform for this particular circuit. Now in this case, what we have done is, we have actually clipped off the positive cycle of the input, and hence we can name this circuit as a positive clipper. But this is also a series clipper because our diode is in series with the input and the output.